That fence changed earthquake science. Before that earthquake, people were still arguing that underground explosions caused earthquakes. There are gases under the grounds that can explode. They thought that these gases were just exploding. Continental drift was not even a theory. That was not till 1912 that was published. And they didn't know anything about mid-ocean ridge spreading, which is what causes most of continental drift. Underneath the oceans are mid-ocean ridges. They're very different in the Pacific than the Atlantic and the Indian, depend upon how fast they spread. The spreading zone south of Baja, California is the fastest spreading zone of the mid-ocean ridges. But they didn't know anything about these ridges. This is where molten lava continually comes up and makes new earth along the crust zippers, if you will. The mid-ocean ridge comes ashore in Iceland. So I took my family for a vacation to Iceland in November because there was a good sale on the hotel and the air flight. And I traveled the world by choosing these really good sales. They had the hotel and the airline included was only like $700 per person for a week in Iceland. I thought it was great. I always wanted to be in Iceland in the winter anyways, but my family wasn't quite as excited about being there in the winter, especially from South Mississippi, as I was. So I would say they did not have as good of a time up there as I did. However, on the bus to the mid-ocean ridge, we were driving, and my husband said, "What is that line in the mountains?" And I said, "That's what we're going to see, the mid-ocean ridge." And he said, "No, that line all the way across those mountains." And I said, "That's the mid-ocean ridge." And then the bus driver, because we were pretty far forward, turned around and started explaining it to my husband. And when we got there, maybe it was 6 feet wide, and you could walk down it. It was the coolest thing. I mean, so cool to be walking on a part of the earth that is continually spreading. So it was cool. The magma wasn't actually boiling at that point in time, but the mid-ocean, because it was crusted over, but the mid-ocean ridges are really cool, and they're what's continually causing the different plates to move, and indeed they're what caused the different plates to exist, separating them with the ridges. So before 1906, they had no way of necessarily arbitrating what was going on, and the fence was taken as conclusive proof that the earth moved. That's why Wigner was able to present his continental drift theory. He had more data, and they started studying how the earth moved, and that's earthquake science. Sometimes there are different kinds of faults, different kinds of situations create different kinds of forcing. There are, however, very few large earthquakes that occur over a 100-year span. There's a lot by damage standards. There's been a couple in Chile, a couple in Alaska, a couple in Japan, you know, the one from Southeast Asia. All of these are called, all of these have occurred on something called the Ring of Fire, which is a circle surrounding the Pacific Ocean with both active volcanoes and large earthquakes. But not enough to form statistically significant data. In particular, the discipline lacked information about the distribution function's tails, the massive earthquakes. We hadn't seen enough nines to have enough data. But we put together a theory that explained everything we had seen. Be careful. The fault off the coast of Japan was supposed to support, at most, a magnitude 8 earthquake. Now, magnitude 8 earthquakes can generate tsunamis, but not the large tsunamis that you typically see. So with only a few case studies, we sort of decided we knew how these puppies behaved. But we didn't. What happened in Japan was the earthquake on the 8 magnitude fault caused an immediate and concurrent earthquake on a nearby fault, which then fed additional energy back to that first fault, causing a larger earthquake. We did not know that there was a feedback mechanism. Is that our fault? Should we have left room for doubt? We typically do not leave room for doubt in science. Leave room for doubt in your programming. Should we have known? In July 9, 869, the Sanriku earthquake occurred off Honshu in almost the same place. Notice this is over 1,000 years ago, because they don't occur that often. This is where the Akats and the Pacific plates meet. It was pretty interestingly described in the Japanese literature. Not very lengthy, but must have been, the person who wrote it must have had a sense of humor. They did massive damage, very similar to 2011. This earthquake is well documented and studied. Moreover, it was brought up during the process of approving that nuclear plant. In other words, some historical scientists said, hey, I understand you think there's only an 8, but 1,000 years ago there was an earthquake on this fault that appears to be bigger than your theory is telling us. Nobody paid attention to that information. Why? That's a question I want you to answer for yourself. Why? Why do people ignore information when it doesn't fit with their picture of what they want the world to be, or how they want something to go, or what their company wants to achieve? They don't do it maliciously, in my opinion, on average. A few people do, not many. They don't do it maliciously. In my opinion, they do it subconsciously. Why? Then there are environmental disasters that are catch-22s. In California, the Pacific Gas and Electric Company used anti-corrosive chemicals in its pipes to fight corrosion. It's a good thing not to have corrosion. Corrosion may well have caused the explosions en masse about a month ago. Although I haven't heard anything else about it. If you guys have figured out the reason, please let me know on Friday. I'm quite not just concerned, but also interested. One of their anti-corrosives was hexavalent chromium. Not good. Decades later, the pipes were old. They were leaking into the water supply in Hinckley, California. There was also a deposition site where they had kept it. This is the disaster that was discovered by Erin Brockovich. You probably have seen the movie with Julia Roberts. If not, it's a decent movie to watch. The real life Erin Brockovich had a few more problems than Julia Roberts, but the point is somebody went out and tested the water. That's all it takes. I'll go on to fracking. If you listen to fracking experts, they will tell you that there's no way that these strong casings and these so if you frack, what you do is to release oil from oil shale from a kind of a rock. A lot of our oil that we've been pumping is in liquid form. Some of it's really nasty liquid like chunks, and mostly we make tar out of that. I'm from the Gulf of Mexico, and there we have something called sweet Louisiana crude. If you can get sweet Louisiana crude, it's nice, it's fluid. You can almost stick it in your car without even doing any cooking, if you will, in the refineries. But when we run out of sweet Louisiana crude and we're having to refine clumpy, icky stuff, the step beyond that is getting the oil directly from rocks. So what fracking is it has the advantage that it can bend its arm so that you're not just drilling straight down and just taking oil from underneath you. it has the technology that turns sideways and moves through rocks to get to where it thinks the oil is. Then inside these shale rocks, they hit this rock with an enormously strong stream of water and very fine sand particles. The particles have to be the correct size, otherwise they're not going to knock the oil out of the rock. So, the second best sand in the country is about 10 miles from my house. So I know the guys who own that land, they have a lot of money right now. So anyways, in the fracking, they're able to move around much more freely underground. They go much deeper. They go through water tables, so that if a leak were to occur in the water table, they would be polluting the entire water table. There are not that many water tables in the country. Massachusetts doesn't have to worry so much. You guys are sort of off with a different water system, but the central part of the United States mostly has one massive water table. You pollute it and the whole thing is shot. From the Rockies to the Appalachians, shot. So, it's important to me that people who are doing this science realize the nature of the danger. They will tell you that it's completely safe. But the first fracking was done on a more limited scale. Some of it was done in Pennsylvania, where they have now discovered several leaks. They don't know where it leaked. They only know that the chemicals they used showed up in wells around the fracking area. So they are being ignored as well. Just like in Fukushima, just like almost everywhere else, they will be ignored. So, I'm going to stop here and then go on with the catch-22.